Hello everyone, we are solving problems on the mesh analysis and nodal analysis. In that, next question is find V1, V2, V3. These are the given circuits. If you observe first circuit, see here V1 means V1 across short circuit. Okay, all these three are connected in parallel. So this is current source, this is 10 ohm resistance, and this is short circuit. Current always chooses short circuit path. This 1 ampere is flowing this path because so this is 10 ohms. Short circuit means 0 ohms. What is R equivalent? If resistors are connected in parallel, R1 R2 by R1 plus R2, 10 into 0 by 10 plus 0, we will get 0 into anything 0. Again it is short circuit. So current always chooses short circuit path. Voltage across short circuit is V is equal to IR. Here current is 1 amps, resistance is 0. So this is 0 volts. That means the voltage across short circuit is always 0 volts and the current is always chooses short circuit path. So here V1 is 0 volts. Now coming to second circuit. Here these three elements are connected in parallel. So in parallel voltage is same. So here what is the voltage? This is 10 volts across all these elements. So V2 is equal to 10 volts. Coming to third circuit. This combination is connected across these two elements. That means the combination of these two elements and this element are in parallel. So you need to apply nodal analysis at here. So here this is V3. V3 means across this current source, this resistor and combination of these two elements. So it is node voltage V3. This is the reference. Now write the nodal equation at V3. This current is coming towards to the node. In nodal analysis, this node has highest potential. That means where we are writing the node equation, that node has highest potential. Current must leave that node, but here current is entering, so it is minus 1. For this V3 by 10, for this branch V3, this is plus, so V3 minus 2 by 5 is equal to 0. Minus 10 plus V3 plus 2V3 minus 4 is equal to 0. V3 is equal to 14 by 3 volts. V3 is equal to 14 by 3 volts. If you observe these three circuits, the voltage across ideal current source. Okay, consider here only this source. Okay, don't consider 10 ohms. Consider only this source. This is ideal current source. In these three circuits, this is ideal current source. This ideal current source, the voltage across ideal current source can be any value. Here we are getting 0, here we are getting 10 volts, here we are getting 14 by 3 volts. This is 14 by 3 volts. So the voltage across ideal current source depends on other elements connected in the network. Next question is find I1, I2, I3. These are the given circuits. In these circuits, if you observe first circuit, the voltage across all the elements are same because all these are connected in parallel. So this is voltage source. So the voltage across this element and this element are same. That is 10 volts. Okay, here it is 10 volts. Here it is 10 volts. Now according to Ohm's law, okay, current flowing through this 4 ohm resistor. See, it is positive. So current is entered here. Let it be I4 ohm. Now what is I4 ohm? I4 ohm is equal to V by R, 10 by 4, 2.5 amperes. Let it be node A. Apply KCL at node A. So what is the incoming currents? I1 plus 3. This current is coming towards to this node and this current is coming towards to this node. I1 plus 3 is equal to, this is leaving the node. So that is 2.5 amps. Now what is I1? I1 is equal to 2.5 minus 3 minus 0.5 amperes. Coming to this circuit, here also voltage is same across all the elements because all the elements are connected in parallel. So the voltage across 4 ohm resistor is like this. This is 10 ohms. So current flowing through this I4 ohm is same as previous. So here 10 by 4, here also 10 by 4. So it is 2.5 amperes. Now apply KCL here, that is node A. So what is I2? Only one incoming current, that is I2 is equal to 2.5 plus 3. So I2 is equal to 5.5 amps. Now coming to here, this is 10 volts, this is I3. So here also all elements are connected in parallel. So here is voltage is same, that is 10 volts. Here also 10 volts. So current flowing through this element is, for passive elements, current is entered positive terminals. Okay, let it be I4 ohm and it is I5 ohm. I4 ohm is equal to, according to Ohm's law, V by R, 10 by 4, 2.5 amps. I5 ohm is equal to V by R, 10 by 5. This is 2 amps. Now KCL at node A. So what is the KCL? Incoming current is only I3 is equal to I4 ohm plus I5 ohm, that is 2.5 plus 2. So I3 is equal to 4.5 amps. Same as previous problem. If you observe all these three circuits, this is ideal voltage source. This is ideal voltage source. Current flowing through the ideal voltage source can be any value. Here we are getting minus 0.5, here 5.5, 4.5. Current flowing through the ideal voltage source can be any value. It depends on elements present in the network. Similarly, voltage across ideal current source can be any value. It depends on elements present in the network. Next question is, find V1. This is the given network. Here current is enter here for 2 ohms. Current is enter here. So the voltage drop across this 2 ohm is like this. This is positive, this is negative. Current is coming towards like this. Let voltage across current source is V2 and voltage across 2 ohm resistor is V3. So what is V3? V3 is equal to IR according to Ohm's law. Current into resistance, that is 2 into 2 is equal to 4 volts. Apply KVL to this loop. So here this is positive. Current is leaving from the positive terminal of this source, that means V1. So it is minus V1. Here current is entering here, so plus V2 plus V3. V3 means 4 volts plus current is also entered positive terminal of this source, so it is 5 is equal to 0. Now what is V1? V1 is equal to 9 plus V2. Here V2 means voltage across current source. We don't know the voltage across current source because it depends on the other elements present in the network. So here exact values are not given. So the voltage V1 is any value. That means voltage V1 can be any value. This is can be any value because this value is depends on voltage across ideal current source. Okay, in the next video we will discuss some more problems. Thank you for watching.